Right, good morning, ladies and gentlemen. Truth is, we don't have any 5G yet. Also, you will have realized we have no summer yet, and that's no school yet, university. But nonetheless, welcome to the 5G summer school here, organized by NORMA and quite a few other players. Cellular has come a very long way, I have to say. So we started quite a while back, 2G, 3G we started. The internet wasn't even running. We're still nailing the Ethernet cables to the walls of the dorm. We're still deploying routers. And we already started actually designing the 3G network. Now, 4G came along when actually we didn't have any iPhone yet out there. We just thought, something will come. We felt it as engineers, started designing the 4G network, and now we're in the very same position again. We as a community have the responsibility to design what we refer to as the 5G network, not understanding really well what will be the next thing to come. We're trying to come to terms, we're trying to come up with KPIs, as we call them, key performance indicators, which somehow justify that we need 5G to come in 2020, 2025. Predictions have always been very lousy, but something will come, we're sure of that, so we'd better get our engineering act together and really start designing that type of system. Now, we have an understanding that 5G will again go in terms of increase of rates, so we want to have 10 times increase of the data rate over the interface. We also understand that probably we'll be going around connecting more things, Internet of Things, hot term, we've been talking about the Internet of Things since 1970 something. So maybe with 5G finally it will happen. Let's see what time will tell. And also the third dimension will clearly be along criticality and reliability of the network. Now, in terms of the first point, the rate, few of you will notice that the cellular capacity has increased over the last 35 years by a factor of about 1 million. Now it's a bit more, 1 million. So that means if you actually digest how much was responsible for what in that factor 1 million, you figure out that the new interface had an impact of a factor of 5 on that. Spectrum had an impact of 25. And making the cells smaller had a whooping impact of 1,600. So you know where the bets are. The bets are making essentially the cells smaller, and that's what's happening. Millimeter wave is a good indication of that. The bets are also that we need probably more spectrum, and clearly the millimeter wave spectrum is a good asset to have in the future. Now, from an architectural point of view, this will give us a lot of challenges, and that's why we, as from the 5GPP NORMA project, which is dealing a lot with the architectural issues, we thought we need to organize that summer school so the audience really understands what it is all about, because a lot of the big questions to be solved are the architectural questions. Now, in terms of delay, in terms of the Internet of Things devices we can connect, we had a few technologies out there trying to do that. We had Bluetooth deployed, and Bluetooth probably is the most successfully deployed infrastructure on the planet, which is not being used at all. About 8% of the whole population is using Bluetooth, even though everybody of us carries a Bluetooth base station with it, right? So it's quite an achievement, really well deployed, totally underused. Now then came Zigbee. We tried with Zigbee. It's going okay, but it's not connecting to billions of devices. We now have the low-power wide area networking systems like LoRa and Sigfox that work well, so my company is using them successfully. But it's clearly not that global standard as 3GPP offers. So let's see if 3GPP gets the act together and comes up with a good solution. Actually, the cellular solution today is already really powerful. We have done some calculus a few years back, and LTA, so the real 4G, is able to connect 15,000 sensors to an eNode B without anybody noticing. 15,000, right? So that's almost 1 billion sensors if you scale it up globally. That's quite an achievement. We want to top it up, really. We want to make sure we can connect maybe 300,000 sensors to a base station to really be able to connect these trillions of devices, enable roaming, billing, authentication, you name it. So it's quite an interesting tech road ahead. We also look into criticality in terms of delay, and I presume that will be discussed quite a lot today. How do we really make sure that we get a very short delay? Is it a millisecond? Is it 10 milliseconds? Is it 50 milliseconds? If you want to know the answer, if it doesn't come up in these 3 days, come and visit our 5G Tactile Internet Lab, where we have experimentation which can show you really what it is in terms of the actual delay we need to cater for. So I wish you a fantastic stay over the next three days, really. I'm glad it's raining outside, because that means you're actually staying inside. I have to say that, just so you know, it's the first time we're using a 360 camera. Okay, so you're all on the screen as I'm on the screen. If somebody doesn't like to be on camera, they should move a little bit up the rows, because we want to really make sure that, you know, we get a 360 view of what's going on. It's an experiment. We don't know whether we're going to publish that, but there's a good chance we will, right? So when people are checking emails, everybody can see that. So just be careful with that, okay? I would also like to say thank you to all the organizers, really, and again, in my team, Vasily, Stan, and all the crew here has made it possible. 5G NORMA and the European Commission are going to stay in the EU for the project support, and of course all the fantastic speakers you will be seeing over the next hours and days. So with that, I'd like to open the 5G NORMA Summer School and enjoy the day. Thank you very much.